Hey guys, welcome to 2016 Level 2 Algebra paper. I do apologize in advance. This video was actually done throughout the day, so be wary that each question might have a different voice level. And also I do apologize in advance for the distractions that actually came in some of the videos. But it's just I'm running short on time and I really wanted to get this video out. Anyway, carry on watching. Starting with question 1. You've basically been asked to simplify this, leaving your answer with positive indices. Now, even if you had done just one step here, I told you guys this is a merit question, but if you had just done this, where you say c squared divided by 3b equals to positive 4, you're kind of starting to go towards an achieved grade. But from here, what you can do is you can expand this out. So you would get c to the power of 8, because 2 times 4 is 8, and in the denominator you would get 3 to the power of 4 and b to the power of 4. All right, just getting this is going to get you an achieved by the looks of it. All right, but if you simplify it, if you use the fourth power correctly, or the correct answer we're looking for is C8 81B4. That's all we're looking for. And that is going to be, I should really put this as A's and M's. So A there and merit there. 5 points for that question straight away. So with question 1b, you've been asked to write this particular quadratic in x minus b squared plus q. This is the completing the square that we did the other day. So with this, all you have to do is you've actually got to work out half of, where's my pens? You got to work out half of negative 8. All right, so I'm going to write it like this. I'm going to write down x squared minus 8x plus 10. Now half of negative 8 is equal to negative 4. All right, and negative 4 squared is equal to positive 16. All right, now I need to have plus 16 here, but I've already got 10 there. Right, so what I need to do is, because I've already got 10 there, I need to rewrite this as plus 16 minus 6. Does that make sense what I've done there? Because I've replaced the 10 with plus 16 and minus 6. Because at the end of the day, that is equal to 10. So I can rewrite this, instead of writing it with the plus 10, I write this as x squared minus 8x, and I put in my plus 16 minus 6. Because at this moment, I've done nothing different between these two equations there. They're the same two equations that I'm working with. However, by writing it like this, now what I could do is I could actually factorize this part. I could factorize this to be x minus 4 squared. And the minus 6 just stays outside as it is. All right, and that gets me an achieved. Question C1, they're asking, show that the solutions of equation, that first quadratic, is 4 times the solutions of the second quadratic. So what we really have to do is we've got x squared plus x minus 56 equals to 0. Now if you want to find the solutions for this, you factorize it. When we factorize this, we're going to get x minus 7, x plus 8. So we can say that our two solutions in this case is positive 7 and negative 8. So already you're kind of halfway there. The second step is factorize this. 4x squared plus x minus 14 equals 0. Now remember what I told you guys before. If you have a quadratic like this, you don't actually have to show us any working. You can, I remember I showed you guys the shortcut with the graphics calculator, how you can factorize it, or even just get the solution straight away. Okay. Factorizing it, I'm going to kind of do it real quickly here, guys. The factorizing the two brackets is going to be 4x minus 7 multiplied by x plus 2 equals 0. Which means my two solutions are, the first one it's going to be 7 over 4. My second solution is going to be negative 2. Now, for this question, if you factorize both equations correctly, you get an achieved. Okay? So basically just doing this part, anything before that part is going to get you an achieved. But if you read the question, it actually says show that the solutions are 4 times the solutions of the other one. So what I would like you guys to have a look at is look at the pattern between these two numbers. 7 over 4 multiplied by 4 equals 7. Negative 2 multiplied by 4 equals negative 8. So that's pretty much what you need to do. So you can just say, so the solutions of the first quadratic is 4 times the second quadratic. And that is going to get you a merit for that question. Alright guys, so in this question we've been asked to find the relationship between the solutions of these two equations, and where they've said that D, E, F is real numbers. Alright, so what I'm going to do is, obviously they're asking us to find the relationship between the solutions. So I'm actually going to find the solutions first. So the first equation I have is dx squared plus ex plus f equals to 0. I know that A is equal to D, B equals to E, and C equals to F. So I'm going to use the quadratic formula. So we've got minus B plus or minus B squared minus 4AC over 2A. And now I'm just going to substitute all these B, A, and C. So I've got negative E plus or minus. B squared is E squared minus 4 times D times F, and the whole thing divided by 2D. And if I simplify this, I'm going to get negative E plus or minus E squared minus 4DF over 2D. Now that's the first equation. So what I'm going to do now is pretty much the same thing, but I'm going to do it with the second equation. So I've got x squared plus EX plus DF equals to 0. So I've got A equals to 1, B equals to E, C equals to DF. So once again, using the quadratic formula, I'm going to actually substitute all these values and try and figure out what the solutions are. So what I have is negative B, so it's going to be negative E plus or minus B squared is E squared minus 4 times 1 times DF, and the whole thing divided by 2 times 1 because A is equal to 1. So when I simplify this, I get negative E plus or minus E squared minus 4DF divided by 2. So from here, I hope you guys can actually see that the only difference between the two solutions is this little d here. All right. So what you could do is you could actually say, if I am going to call this my first quadratic, so my first quadratic is this, and then the second quadratic is this. I could actually say that if I take the first quadratic, the solutions from the first quadratic, and I multiply it by d, then I should get the solutions for the second quadratic. So I guess that's basically it. You could actually say, because you can see that, look, the only difference is d. And if I take the first equation, first solutions, so I'm talking about, I'm going to do it in here. So negative e plus or minus square root of e squared minus 4df divided by 2d. So this is the solutions for the first quadratic. And if I multiply it by d, I actually see that 2d's cancel out. And what I'm left over with is the solutions for the second quadratic. So a nice little statement, guys, would be good. So we just kind of, I mean, you don't need to prove it like this. I mean, you can just write it as a statement. So you can say solutions for second quadratic. Just write that. Second quadratic is d, oh, sorry, making a lot of mistakes, is d times the solution for the first quadratic. So guys, this is an excellence question, and I think you need to get up to the last point to get excellence. For merit, I think just finding the two solutions is merit.
So did I drop anything?
Yeah, apologies about the disturbance there. Where were we? Achieved. You get an achieved for finding one of these solutions. Okay, and that's basically it, guys, for this question. All right, so all I know is the first thing is first. I've got my two solutions here that they've given us. The first solution is -half, and the second solution is 2/3. Now remember, I talked to you guys about this before. When you have solutions with fractions, you can write it inverse. Like for example, if I have a solution of -1, then I know the factor could be written as x plus 1. If I have a solution of +2, then I can write this as x minus 2 as a factor. Now, I know we did this in class, like if you have a solution of -half, you could potentially write it like this, can't you? 2x plus 1. And then if you have a solution of 2/3, you could write it like this, 3x minus 2. And that's basically it, guys, because I've got my quadratic right there. Because this, if those are the two solutions, these are the two factors. If I expand this, I'm going to get 6x squared. 2x times -2 is -4x. 1 times 3x plus 3x. 1 times -2 is that. Simplify it. I got 6x squared minus x minus 2. Guess what? You got your a value. A is 6. B equals -1. C equals -2. That's all you need to do. What I need you guys to have a look at this is there is other possible values for A, B, and C as well. Why? Because if we were to follow the logic that I have on the right hand side here, if I have my two solutions as x equals -half and x equals to 2/3, then potentially I could have a quadratic that also looks like this, x plus half multiplied by x minus 2/3. All right, and that's where the other values of A, B, and C potentially could come from, because we don't know which one it is that these solutions came from. We don't know whether it was the quadratic on the left hand side or the quadratic on the right hand side. So we just mentioned that there are going to be other values for A, B, and C as well. Alright guys, so for this question, you've been asked to find positive integer values for k so that this quadratic equation has real rational solutions. Now, a couple of things to understand about real rational solutions. What they're trying to say is that, so say there's a parabola, right? When you have those two solutions there, those two solutions, they've got to be nice numbers. So they're not like really long decimal numbers. Ideally, rational numbers. Okay, now if you're not sure what rational numbers is, have a quick look at search on Google and see what they are. And for us, we're looking for positive integer values of k as well. So the first thing we're going to do is we're going to actually have to do a discriminant, because a is equal to 2, we got b equals to 4k, and c equals to 2k squared plus 3k minus 11. Now the reason we're going to be doing a discriminant is because obviously we want this discriminant to be a perfect square. Because if it's a perfect square, then just think about it. You know how a discriminant is like minus b plus or minus the discriminant square root of that divided by 2a. If it's a perfect, that little triangle there, which is discriminant, if it's a perfect square, then your numbers are going to be really nice. It's going to be rational. But if it's not a perfect square, then it's going to be, the numbers are going to be irrational. So it's going to be like decimal places and so on. So let's just work out what the discriminant is first. So we have 4k squared minus 4 multiplied by 2 multiplied by 2k squared plus 3k minus 11. Now also, the discriminant has to be greater than or equal to 0 for this to have real or rational solutions. Sorry, real and rational solutions. So we're going to have this as greater than or equal to 0. So expanding this, we've got 16k squared minus 8 times 2k squared plus 3k minus 11 is greater than or equal to 0. So expanding the brackets, we've got 16k squared minus 24k plus 88 is greater than or equal to 0. Simplifying this, we have negative 24k plus 88 is greater than or equal to 0. So negative 24k is greater than or equal to minus 88. And k has to be, remember that when we divide by a negative number in inequalities, we've got to swap the sign, and so this will end up being k is less than or equal to 11 over 3. Now, in terms of positive values for k, what we do know, k has to be less than 11 over 3. So really, we've only got 3 numbers to look at, because first off, we can't have k equals to 0 because it's not possible. As told, k is positive. We can look at k equals to 1. If k is equal to 1, then the discriminant, and I think the discriminant, I've actually simplified it all the way down here to that. I mean, guys, if you really want, you can actually substitute k as 1 in there as well. But obviously, I've actually simplified it all the way from there to here. So I'm actually going to use that. So when k is equal to 1, I've got negative 24 times 1 plus 88. And that is equal to 64. So this 64 is 8 squared, so it's a square number. If I put k equals to 2, I get negative 24 times 2 plus 88. And that's equal to 40. Now this is not a square number. And when I put k equals to 3, I get negative 24 times 3 plus 88. And that's equal to 16. Also a square number. All right, now, and we can't obviously have k equals to 4 because we know that k has to be less than or equal to 11 over 3. So the only possible solutions for k, only possible values for k is 1 and 3. Okay, now guys, if you fully don't understand this question, what I would recommend you to do is I would recommend you to take this particular equation, just put in y equals to this equation in Desmos, add a slider for k, and put k equals to 1, 2, 3, and look at what happens at the solutions, and you'll kind of understand what I'm trying to do with this particular question. Okay, so in terms of what you need for achieve merit excellence, excellence obviously is the final part here. Merit is looks like multiple categories for merit, but this is one of the categories. If you get 11 over 3, for achieved value substituted into discriminant. I think for achieved, you're just looking at that. There you go, easy marks there. All right, guys, that's it for this question then. So question 2a, it's asking you for correct discriminant. So before you even start, the first step you want to be doing is rearranging this equation. So you want to write this as x squared minus 10x minus 3 equals to 0. Now, discriminant is b squared minus 4ac. So we know that this is going to be negative 10 squared minus 4 multiplied by 1 multiplied by negative 3. So we've got 100 plus 12. 112 is your answer. Nice and easy achieved there. 2b. Question 2b, it's asking you to simplify this. All right. Now, log rules. With log rules, we know that this could be written like this. We have 4 log u cubed over log u. Now remember, if there is a power, you can actually bring it to the front. So this would become 3 multiplied by 4 log u divided by log u. So what do you have? 12 log u divided by log u. The 2 logs cancel out, and all you're left over with is 12. And that, ladies and gentlemen, is a merit question. Okay, and if you just get up to this part here, you get an achieved. So we've got Mary that's buying a new car, which is 25,000 roughly. The car's value decreases continuously by 12%. So we know that we can write this as a rate. And when something is being decreased by 12%, we can write it as 0.88. For those of you that have forgotten it, you can write it as 1 minus 12%, which is the same as saying 1 minus 12 over 100, and which equals to 0.88. So the value of the car, P, is t years after she first bought it, can be modeled by this function here. How long will it take for the car to halve? So the first thing you want to do, you want to find half of 24,990, which is $12,495. So we're trying to figure out at what time. what year is it? Yeah, what year is the price of the car going to have? So we have our equation, which is P equals ART. P in this case is 12,495. A is 24,990 multiplied by the rate at which it's decreasing, which is 0.88, and T, which is unknown. So rearranging this, we've got 12,495 divided by 24,990 equals 0.88t. Well, really, we've got 0.5 equals 0.88 to the power of t. From here, guys, you take log of both sides. So you've got ln of 0.5 equals ln of 0.88t. And then what we're going to do is we're going to write t in front of the ln. So it's going to be t multiplied by ln of 0.88, which means t is equal to ln of 0.5 divided by ln of 0.88. So what ends up happening is when you put this in the calculator, you should get t is equal to 5.422. So basically, guys, you can say it takes 5.422 years for car to halve its price. Okay, so in terms of grades, you're looking at excellence, not excellence, sorry, apologies, false alarm, merit for the time that's actually found. And even if you if you just put the correct answer, so this is a good one. I mean, like some people like to use the graphics calculator for this. If you guys use the graphics calculator and just put the answer without any working, you're only looking at an achieved. But if you set up the equation, but you make a mistake somewhere along the way, you could still get an achieved. Okay, that's basically it for this question, guys. All right, so with question 2D, you've been asked to solve this log equation. Now, the formulas are given to you guys, so all you have to do is rearrange this equation. You have 8 to the power of 2/3 equals x. And if you solve it, put it in your calculator, and you get x is equal to 4. And that's basically it. Another achieved. Okay, now this question, it says solve this equation, 6 log 8x squared plus 2 log 8x minus 4 equals 0. Now, your first kind of thinking is like, oh, I can actually manipulate the log functions. And I'm going to say this to you guys, and hopefully this is a useful tip for you guys, is that anytime you're dealing with whether it's logs, exponentials, and they do this quite a bit in NZQA, I'm sorry, the NCEA level 2 maths papers, it's a good idea to actually have a look at this and just have a look at the powers that you're dealing with here. Here, you've got a squared. Here, you've got a 1. And then here, you've got a constant by itself. And I guess what I'm trying to get you guys to look at is you're potentially dealing with a quadratic with a constant here. Because what I'm going to show you guys is this. What if you take p equals log of 8x? Now, if you were to do that, you are going to get 6p there. 6p squared plus 2p minus 4 equals 0. And suddenly you've got this quadratic that's actually right in front of you. Okay? And you can put this quadratic in your graphics calculator to get the two solutions for p. The way I do it is 6 times negative 4 is negative 24. So I'm looking for two numbers that multiply to negative 24 and add up to 2. So obviously it's going to be 6 and negative 4, 6 and negative 4. So this is how I would do it, guys. 6p squared plus 6p minus 4p minus 4 equals to 0. Factorize this. So I've got 6p, p plus 1 minus 4 times p plus 1 equals 0. So factorizing this, I got 6p minus 4 times p plus 1 equals 0. Therefore, p is equal to 4 over 6 or negative 1. Okay, so once I have that, well, I did say log 8x was equal to these things. So I could actually put log 8 of x equals to 4 over 6, which means 8 to the power of 4 over 6 equals x. So that is one of my answers, which I know that can actually simplify to 4 if I put that in the calculator. And then the other one is log 8x of negative 1, which means 8 to the power of negative 1 equals x, and I'm going to get 1 over 8 equals x. So basically my two solutions are x equals to 4 and 1 over 8. And that's basically it. So for excellence, you're looking at your final answers. For two values of u, so I guess if you get up to here, you're actually looking at a merit. Achieved is just the answer itself, and achieved you can actually get just by doing this part here. And that's basically it for this question, guys. Alright guys, so with this question, what you have is a triangular garden has sides with lengths in ratio 3 to 4 to 5. Okay, now it doesn't actually tell us it's exactly 3 meters or centimeters or whatever, but it's just in ratio of 3, 4, and 5. So what I'm going to do is I'm going to call x, for example. Let x be some number, or in this case, I'm going to say that the bottom here is 3x. That side there will be 4x. Then the longest side is going to be 5x. All right. So that's the first thing I want you guys to actually get at. Now they say the path is 1 meter wide. So that part from there to there is 1 meter. From there to there is 1 meter. And then from there to there is another 1 meter. At each corner of the garden, the path is a sector part of a circle with a radius 1 meter. Basically what they're telling you is that is, so basically zone A, zone B, and zone C form a circle. Now it says the difference between twice the total area of the path and the area of the garden is 2 pi. Okay, let's work out area of the garden first. Okay, now the area of the garden is going to be the area of the triangle, because that's the triangular garden. So if I work out the area of the garden first, which is the triangle, the area of a triangle is half times base times height. So I have half multiplied by 3x multiplied by 4x, which is going to give me 6x squared. So that's the area of the garden. Now as for the area of the path, I have, damn it, I should have used a different letters, but area of the path is going to be basically, that I'm shading here, this light blue stuff, the yellow range here, and the orange range here. Now the light blue area is 3x times 1, so that's going to be 3x. The gold one is 4x times 1, so it's going to be plus 4x. And then the orange one is 5x plus 1 times 1, which is 5x. So then the area of the path should also include that little circle there. And if you think about it, the area of the circle, the area of path plus area of circle, the area of circle is pi r squared with a radius of 1. So we can just put that as pi times 1. So what we really have is the area of path is 12x plus 1 pi. So now let's actually try and work the question out. It says the difference between twice the total area of the path. So we've got 2 times area of path minus area of garden equals 2 pi. That's what we have. So then we could say 2 times 12x plus pi minus area of garden is 6x squared equals 2 pi. So when we expand this, we're going to get 24x plus 2 pi minus 6x squared. I'm going to bring the 2 pi, rearrange it. So minus 2 pi equals 0. So what I then have is 24x minus 6x squared equals 0. Factorizing this, I'm going to get 6x times 4 minus x equals to 0. Therefore, x is equal to 0 or 4. Now, we can't really have x equals to 0, because if x equals to 0, then the triangle has a base of 0, height of 0, and like the other length is 0. So then we actually have to say that x is actually equal to 4. Now, have we answered the question? Because I don't think we have. Look at that. Finally, it says find the length of the longest side of the garden. The longest side of the garden in this case is 5x. So it's going to be 5 times 4, which equals to 20 meters. And that is the longest side. Okay, and that's what you got, what you need for an excellence. Quadratic solve for y. So I think if you get up to here, you're looking at a merit. Quadratic establish is an achieved. So I think for an achieved, you almost have to be looking at somewhere here or before that. And guys, that's basically it for this question. Question 3a is asking you guys, where would the graph cut the x-axis? So all you're really doing is putting 0 equals 12x squared minus x minus 6. Now if you have a graphics calculator, you put that in a quadratic formula and solve your two answers. For me, I know that if I factorize this, I'm going to skip that step a little bit. I'm going to get 4x minus 3 and 3x plus 2, which means my two solutions are positive 3 over 4 and negative 2 over 3, which is going to give me an achieved straight away. So with 3b, you've got a bit of rearranging to do. All right, so we've got log x 216 equals 3. So we can say that x to the power of 3 equals 216. That means x is equal to 3 root 216. Now, you can actually leave your answer like this. All right, and that should get you an achieved. If you want to solve it, you can put that in the calculator and you should get an answer of 6 as well. All right, guys, for this question, you've been asked to rearrange the following formula to make x the subject. All right, so obviously we've got x on both sides. So what I'm going to do is I'm going to cross multiply. So I got 4x over 5 equals y multiplied by x plus 3 over 2. Cross multiplication, I get 2 times 4x equals 5 times y times x plus 3. I then expand the brackets, so I've got 5y, I'll do one more step, multiplied by x plus 3. So I'm going to get 5yx plus 15y. Rearranging this, I'm going to get 8x minus 5yx equals 15y. X is a common factor, so I can take that out. Now 8 minus 5y equals 15y. Therefore, x is equal to 15y divided by 8 minus 5y. So, merit for that. Achieved is just getting x's, all the x's into one side. Okay, that's basically it for this question, guys. We'll go to the next question. So, in this question, you've been asked to solve this equation. It looks complicated, but in reality it is not, guys, because look at this. All you have to do is you have to look at the numbers and see if there's a pattern. Obviously you've got these three numbers here, 9, 27 and 3. Now know that 9 we can write that as 3 squared, 27 we can write that as 3 to the power of 3. So what I'm going to do is I'm going to replace 9 in this equation here on the left hand side with a 3 squared. So I'm going to write that as 3 squared to the power of 8n plus 6 equals 27. I'm going to replace it as 3 cubed to the power of n squared minus 1 multiplied by 3 to the power of 1 minus 3n. So the next step I'm going to do is I'm going to actually make everything to the power of 3 itself with the same base of 3. So here I'm going to get 3 to the power of 16n plus 12. In the next one, I'm going to get 3 to the power of 3n squared minus 3 multiplied by 3 to the power of 1 minus 3n. And basically, because they all have the same base of 3, I could say that 16n plus 12 equals, because remember when you multiply two exponents with the same base, you add their powers. So 3n squared minus 3 plus 1 minus 3n. So I can make this into a quadratic now. 3n squared minus 3 plus 1 minus 3n minus 16n minus 12. Simplifying this, I have 3n squared minus 19n minus 14 is equal to 0. Now guys, you can put this in the graphics calculator and get your two answers. I'm going to factorize it real quickly. Look, I'm not going to waste the time here. I know what the two factors are going to be in this case. It's going to be 3n plus 2 and n minus 7. Now you can use the quadratic formula if you want to, if you don't know how to use a graphics calculator. But basically, I get the two values for n because 3n plus 2 equals to 0, or n minus 7 equals to 0. And in this case, n equals negative 2 over 3, or n equals to 7. So, grades wise, looking at excellence for these two things, merit up to here, and base change to 3, achieved for that one there. And that's how you solve this question. Alright guys, with this question, what we have is a symmetrical bridge, 40 meters apart, and its supporting cables, the towers that support the cables are 15 meters high. And we've given some information at the lowest point. What have we got at the lowest point? At a point midway between the towers, the height of the cable is above the road is 3 meters. So the distance here is 3 meters. Alright. And it says use algebra to show that the post is 6 meters high when the vertical post is 10 meters from the center. Okay. How do we go about this question? Now, for those of you guys that have actually done graphs, I would probably say the best way to do it is to actually write an equation of a parabola. So what I would do is, if I was going to do this as a parabola, I would actually put my y-axis through there, and obviously my x-axis through there. So I can actually say y equals to ax squared plus c. Now, because the graph is shifted up by 3, that's my 3 meters there, I can say y equals to ax squared plus 3. Now, I got to figure out what the a value is. The only other information that I know is this point right here, because from the center to that edge, I can write this as a coordinate as 20, 15. So if I substitute 20 and 15 here, I should be able to get my a value. So 15 equals a times 20 squared plus 3, and rearranging this, I'm going to get 12 equals a times 400, which when I rearrange, I'm going to get a is equal to 12 over 400, or I could say a is equal to 3 over 100. Okay, so then my equation for this bridge is y is equal to 3 over 100 x squared plus 3. So when it's the 10 meters distance, when it's 10 meters away from the center, I say that x is equal to 10. So y is equal to 3 over 100 multiplied by 10 squared plus 3. And I end up getting 3 over 100 times 100 plus 3. And as you guys can see, 100 cancels out. You got 3 plus 3, and that's equal to 6 meters. And basically, guys, one grade for this question. It is direct merit. All right, let's go to the next question. Okay, guys, so this is basically a follow-on from the previous question. I'm going to have my y-axis right through the middle there, and I'm going to have the x-axis there. So some of the points that I already know, this point here is 0, 3. This point here is 20, 15. Point B, it's going to be 30, 0. I'm only looking at point B at the moment. It's 30, 0. The way I figured it out was I went 60 minus 40, which is 20. That means from here to here is 10. And then from A to this point here is another 10. So that's how I figured out that B, the point B is at 30, 0. So what I need to figure out is I'm looking for the distance CD. I already know what the distance from C to here is, right? I already know what that is because that is 10. Sure it is, but let's work it out anyway. And I need to figure out what this little distance here is right now. So the way I'm going to do it is first I'm going to write the equation for this parabola here. So I know it actually looks like this. Y equals to a times x minus 30 squared. All right. The reason I know that is because this parabola has actually shifted 30 units to the right. So that's how we write it, x minus 30 squared. There is no vertical shift, so we're going to leave it as it is. The next thing I know is that this same light blue parabola has a point at 2015. So then I can write this as 15 equals a multiplied by 20 minus 30 squared, which is going to be 15 equals a times negative 10 squared. 15 equals a times 100, and a is equal to 15 over 100. So the equation of that light blue parabola, that second extension, is 15 over 100 multiplied by x minus 30 squared. So now what it says is that I need the distance CD between the two parabolas at a height of 6. So basically I need to figure out what the coordinates of D is. All right. I know the value of y in D. So I know that D equals x comma 6 because I know it's 6 meters, the same height as C. So because that's 6, then I can substitute this in the light blue parabola equation, which is y equals to 15 over 100 multiplied by x minus 30 squared. So what I then have is y is equal to 6. So 6 equals 15 over 100 multiplied by x minus 30 squared. Rearranging this, I'm going to get 600. So 6 times 100 equals 15 x minus 30 squared. And then 600 divided by 15 equals x minus 30 squared, which gives me 40 equals x minus 30 squared. Keep going, guys. You're going to get x minus, taking square root on both sides. So x minus 30 is equal to plus or minus 40. All right, remember that there's actually two values for square root of 40. So x is equal to 30 plus or minus 6.32. So my two values for x is 36.32 roughly and 23.68. So basically what I've figured out is the coordinate of D is actually 23.686. Now the reason I'm not choosing 36.32 because 36.32 is actually here on that side. That's 36.32. And I need to figure out what CD is. Now remember, C we found in the previous question as 10,6, which means the distance between C and D, so the distance of CD distance is going to be 23.68 meters minus 10 meters, which equals to 13.68 meters. Guys, that's basically it for this question. So excellence if you get right to the bottom. Model for second parabola given and used to find value of x. That's achieve, no, not achieve, merit, I'm sorry. Getting up to here is merit. And I don't think there's any achieved questions attached to this. Alright guys, that's basically it for this video. Thank you for watching. If you have any questions or comment, if you have any questions, pop it in the comments below and I'll try my best to answer them. But apart from that, thank you for watching. Oh, and I do apologize about the noise and the distractions that came by. It's getting harder to record these videos. But anyway, see you later.